Okay, so the first thing on this question, which was part of the pretest, is to look at the diagrams. And the question starts here. It says the diagram shows the movement of molecules across a cell membrane. And I've got before and I've got after. I've got outside the cell and inside the cell. So I'm going to start with this one. And the first thing here, I know that this bit here, I can see the heads and the tails, so I know that that is the cell membrane. So I'm going to label that cell membrane. And then the next thing over here, I've got a key. So these big spots here are glucose, and the little dots are H2O, water. So I'm going to count the molecules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I got 16 molecules out of water outside the cell to start off with, because this is before. And I've got 1, 2, 3 inside. After, I've got 1, 2, 3, 4, 5, 6, 7, 8 on the outside, and I've got 1, 2, 3, 4, 5, 6, 7, 8 on the inside. So by looking at writing my numbers down, I can tell that water has moved from outside the cell, it's gone to inside the cell. So it's gone in that direction. I've gone from the high number to the low number. So I've gone from high to low, which means I'm going downhill. So I know that this must be passive. Okay, it's passive because when you go downhill, you don't need any energy. Okay, and because I'm talking about water molecules, I also know that this is osmosis, because osmosis is the way water molecules move from where there's more water to where there's less water, from high to low. Okay, now I'm going to count the glucose molecules. 1, 2, 3, 4, 5, 6, 7 on the outside before, and 1, 2, 3, 4 on the inside. After, I've got 1, 2, 3, 4, 5, 6, 7 on the outside, and 1, 2, 3, 4 on the inside. So the number of glucose molecules has not changed. So I know that glucose has not moved into the cell or out of the cell. Okay, so now I can look at the question choices. Which of the following conclusions can be drawn? So only water molecules move into the cell by diffusion. That is true, because only the water molecules moved, the glucose didn't. Only glucose molecules move in by active transport. Well, I know that's wrong because the glucose numbers did not change. Both water molecules and glucose molecules move into the cell by cell diffusion. Well, they didn't, because glucose did not move, and both water and glucose. So I know, so that's how I got that answer F, and I did it literally by counting numbers and seeing which direction the water molecules moved. So did they go from a big number to a small number, or a small number to a big number? Okay, so that's why that's the correct answer. Now I want to look at this question. Okay, this one right here. So it says a type of cell transport is shown. So I'm looking at my diagram. Immediately there I see my phospholipid bilayer, my 2 layers of phospholipids, so I know that that's the cell membrane. Okay, so I always label where my cell membrane is. And I can see an arrow, and I've got 1, 2 here, so I'll write the 2 there, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think there's 13 there. So I know I'm going from the arrows going in this direction. I'm going from low to a high number, so I'm going against the concentration gradient. And there's another big clue here. If it takes ATP, we know that energy is being used, which means that this has to be some type of active transport. Okay, so let's look at the answer choices. Which description best describes this type of cellular transport? active transport because energy is being used to move molecules against the concentration gradient. Check, because we are going from low to high, so we are going against, right? Remember, against the concentration gradient. Anytime you're trying to put something where there's less of it, move it to where there's already more of it. Facilitated diffusion? No, it can't be, because diffusion, anytime I see diffusion, I know it is passive. Osmosis is the diffusion of water. There is no word water in there. It doesn't show it anywhere. Endocytosis, well, endocytosis is when you take large molecules by engulfing in the cell membranes. So I know none of these are the correct answer. Again, the clues that A is the right answer. We're going from a low number to a high number, and it's using energy. Now, this last question down here, right, the answer choices are actually on the other side. Transmembrane proteins span the width of 4 types. If you think about it, if this is the outside of the cell and this is the inside of the cell, right, the cell membrane, which is here, right, this part here, the cell membrane is allowing stuff to go from outside the cell to inside the cell, or from inside the cell to outside of the cell. So this cell membrane is the boundary between the intracellular and the extracellular. Okay? So when we look at the answer choices, although these proteins have different specific functions, they all stop chemical reactions. Right? No, they don't stop chemical reactions. They're not, part of the metabolic pathway. And we're not synthesizing molecules. That means we're making new molecules. No. But look at what C says. Helps the cell interact with its external environment. So here's the inside of the cell. Here's the external environment, the extracellular environment. And that the cell membrane is like the boundary between the extracellular, the outside environment, and the inside of the cell. That is why C is the correct answer, right? So that's these questions.